Welcome to the Deep Dive. Today, we're going straight into something really fundamental, something you interact with, well, constantly, probably without even thinking about it.
Yeah.
The International System of Units, SI.
The modern metric system.
Exactly. And here's something that kind of blows my mind. It's the officially recognized measurement system in, well, almost every single country on Earth.
Yeah, the scale is huge.
Think about that. From tiny scientific experiments to, figuring out how much pasta to cook for dinner.
Right.
The SI is this invisible framework, really holding our understanding of the physical world together through measurement.
It really is. It's like a universal language, and it underpins, well, everything from cutting-edge tech innovation to just your everyday trip to the market. So in this deep dive, we're going to unpack the very core of this system. We'll look at its foundations, how it's all organized, and ultimately how it gives us this incredibly standardized way to, perceive and quantify the world.
Exactly. And for this, we've gathered some really interesting insights into the SI's fundamental definitions, its history, quite a journey there, and the global bodies that actually govern it.
Right, the BIPM, CGPM.
Yeah. Which brings us to a question for you listening. Have you ever stopped to think about why a meter is exactly a meter? Or where these seemingly absolute standards even come from?
It's a good question.
Well, that's what we're aiming to explore today, and maybe reveal some surprising things about this seemingly straightforward system.
Okay, so let's dive right in. The bedrock, really. The defining constants and the 7 base units that come from them. What's truly remarkable, I think, is that the whole SI framework rests on just 7 defining constants.
7, that's it.
7. And these aren't just, random numbers. They represent really fundamental aspects of the universe itself.
Okay, 7 constants founding all our measurements. Sounds incredibly powerful. What are they?
Okay, so we have the hyperfine transition frequency of cesium. That's the one for the second.
The atomic clock thing.
That's the one. Then the speed of light in a vacuum, the Planck constant, elementary charge, Boltzmann constant, Avogadro constant, and finally, the luminous efficacy of a specific frequency of light. Each one has a fixed, exact numerical value when you express it in its SI unit.
Whoa, hang on. So they're not values we measure and might get better over time. Yeah. They're just declared, and everything else fits around them.
Precisely. That's the shift. They are defined as exact now.
That really changes how you think about it.
Yeah.
Okay, so from these 7 constants, we get our 7 base units.
Yeah.
The fundamental building blocks.
Exactly right. These constants directly underpin how we define the 7 SI base units. So we're talking about the second for time, the meter for length, kilogram for mass, ampere for electric current, Kelvin for thermodynamic temperature, Kelvin for thermodynamic temperature, Kelvin for thermodynamic temperature, the mole for amount of substance, and the candela for luminous intensity.
Right, got it. The cornerstones. SMERA, KG, AK, mole, CD. The essential toolkit for quantifying reality, sort of.
You could say that, yeah.
But how exactly do the constants define the units? Can you give us, a concrete example?
Sure. Let's take the kilogram. This is a big one that changed recently.
Right.
Its definition is now tied really intricately to the Planck constant. The one linking photon energy and frequency?
With quantum stuff.
Oh, basically, yeah. The kilogram is defined by setting the Planck constant to a specific, absolutely exact value. 6.62607015 times 10 to the minus 34 joule seconds. And this definition cleverly folds in the definitions of the meter and the second, too.
Okay.
So the math gets a bit involved, but you can think of it like the kilogram is now fundamentally tied to this universal constant through energy and time. It's not about a physical thing anymore.
So wait, that famous platinum iridium cylinder, the one locked away in France, that's not the kilogram anymore?
Nope. It's now a historical artifact, incredibly important historically, but the definition doesn't depend on it.
Wow. Okay. So the kilogram weight in my kitchen scale is ultimately defined by the Planck constant.
In principle, yes. That was the huge impact of the 2019 redefinition. We'll probably circle back to that.
Yeah, we should.
But yes, these base units anchored to these constants. They're the foundation. And the crucial thing to grasp is that every other SI unit, and there are loads of them, can be expressed just using combinations of these 7 base units.
Right.
They form this fundamental set for analyzing how different measurements relate to each other.
Okay, solid base established, 7 units grounded in constants. But what about measuring things that aren't quite so basic, like speed or force or energy?
Ah, right. That's where derived units come in. We start combining the base units.
Combining them. How?
Well, It's actually pretty straightforward. Derived units are just created by multiplying and dividing the base units. Think of them like recipes using the base units as ingredients. And there's a particularly useful type called coherent derived units.
Coherent? Okay, what makes them coherent? What's the key idea there?
Coherent just means the numerical factor in the relationship between the derived unit and its base unit parts is exactly 1. No messy conversion factors needed.
Clean, like...
Like velocity. The classic example. We measure it in meters per second, ems.
Yeah.
It's just the base unit for length divided by the base unit for time, factor of 1, direct, clean relationship.
Got it. Simple and direct, meters per second. But I also remember units with, like, special names. Hertz, newtons, joules. Where do they fit in? Are they coherent?
Excellent point. Yes, many of them are. The SI is actually given special names and symbols to 22 of these coherent derived units.
22. Wow.
Yeah, it makes life much easier, honestly. Stops us having to write out complex combinations all the time.
Okay, give me some examples.
Sure. Hertz, symbol hertz for frequency. That's just 1 cycle per second, so it's inverse seconds in here. Coherent.
Okay.
Then you have the Newton, N for force. In base units, that's kilogram meter per second squared. Kg MOC. Still coherent.
Right.
Exactly. Energy is the joule. J. That's kilogram meter squared per second squared, kg insul, also coherent. Or you can express it as a Newton meter, work, and power, that's the watt, W, which is joules per second, J or S, or in base units. kg again, coherent. Yeah. These names are just convenient shorthand.
That is a huge convenience. Imagine saying kilogram meter squared per second cubed every time you talk about a light bulb.
Right. So 22 of these name shortcuts.
And what about things like radians and steradians? From geometry class. Angles.
Yes. Radian and steradian, they're interesting. For historical reasons, they are treated as derived units, even though technically they're dimensionless.
Dimensionless? How?
Well, a radian is defined as a ratio of arc length to radius length divided by length, so the units cancel. Same idea for steradians with areas.
I see.
But they are absolutely essential, especially in physics and engineering, for expressing lots of other derived units involving angles or rotation, so they have this special status.
Okay, dimensionless but crucial players. Got it. And the building doesn't stop there, right? We can combine base units and these named derived units.
Oh, absolutely. You mix and match as needed, take pressure. The SI unit is the Pascal, Palais.
Right.
But the Pascal itself is defined as 1 Newton per square meter. N.
So you're using the derived unit Newton in the definition of another derived unit, Pascal.
Exactly. It builds. Newton is derived from base units, Pascal is derived from Newton and a base unit. The system is really flexible that way. You can create derived units for pretty much any physical quantity you can imagine.
Okay, this is making sense. Base units from constants, derived units from combining base units, sometimes with special names, and you can even derive units from other derived units.
You got it.
But what about scale? You know, measuring the distance to the next galaxy or the size of an atom. Meters and kilograms aren't always the most convenient scale.
Absolutely not. And that's where the metric prefixes come in. They're the solution for handling this huge range of scales we encounter.
Prefixes, like kilo or milli.
Exactly. These prefixes let us express decimal multiples, making things bigger, and submultiples, making things smaller of the units in a really systematic way.
So instead of saying 1,000 meters, we just say
1 kilometer, much neater. That kilo prefix just means multiply by 1,000 or 10 meters.
Definitely more manageable, especially for big numbers. So these prefixes are basically shorthand for powers of 10.
Precisely. And the SI provides a whole standardized set of them. Currently, there are 24 official prefixes.
24? Wow, what's the range?
It's vast. They go from the incredibly tiny, like quecto, which is 10 years.
Mine is 30. Good grief.
All the way up to the unimaginably large keta, which is 10 years.
Positive 30. That is just staggering. Can you even think of something measured in, like, keta meters?
Maybe the estimated diameter of the observable universe expressed in meters. It puts everyday scales into perspective, doesn't it?
It really does.
And interestingly, these newest prefixes, queta and quecto, along with rana, ten, and roroing, were only adopted in 2022, so the system is still evolving.
That's recent. Okay, any rules for using these prefixes?
Yeah, a couple important ones. First, you never stack them. You don't say millimillimeter, you'd say micrometer.
Okay, one prefix at a time.
Right. And the second is a bit of a quirk related to mass. Even though the kilogram is the base unit, prefixes are applied to the gram. So 1/1,000,000th of a kilogram isn't a microkilogram, it's a milligram, mg. 1,000th of a gram.
Oh, okay. Milligram, not microkilogram. That's a key detail. Good to know. Now, circling back to that coherent idea we talked about, how do prefixes affect coherence? If a meter is coherent, is a kilometer still coherent?
Good question. And the answer is generally no. Remember, coherent units have that numerical factor of exactly 1 when expressed in base units.
Right.
When you add a prefix, you're introducing a factor other than 1, like 1,000 for kilo. So while the meter is coherent, the kilometer, or 1,000 meters, is non-coherent.
Okay, so adding a prefix usually breaks the coherence. That means many of the units we use day to day, like kilometers, milligrams, milliliters, they aren't technically coherent.
Technically, no. It's a subtle distinction, but important for the system's internal logic. Most prefix units are non-coherent.
Most, but not all. Is there an exception?
There is one very important exception: the kilogram.
Even though it has kilo right there in the name.
Exactly. Despite the prefix, the kilogram is the coherent base unit for mass.
Okay, why the special treatment for the kilogram?
It's purely historical convention. Back when the metric system was first being developed, the kilogram was initially conceived as the base unit for mass.
I see.
So the habit of applying prefixes to the gram, milligram, microgram stuck even after the kilogram was formally adopted as the base unit in the SI structure. It's a historical hangover, basically.
Got it. A little quirk we live with. Now, one more thing on coherence. You mentioned earlier that sometimes different quantities can share the same coherent SI unit, like JK.
Yes, that's right. Joule per Kelvin, JK, is the coherent SI unit for both heat capacity and entropy, 2 different physical concepts.
Okay.
Similarly, the ampere A is the coherent unit for both electric current and something called magnetomotive force.
So how do we avoid confusion then, if the unit is the same?
Context.
Yeah.
It absolutely highlights why you must always specify the quantity being measured, not just state the unit. The unit alone, like JK, doesn't tell the whole story. You need to say the heat capacity is XJK or the entropy is YJK.
Makes perfect sense. Context is king.
Yeah.
Okay, this whole sophisticated system, it obviously didn't just appear overnight, fully formed. It must have a history.
Oh, definitely. A fascinating one. The drive towards the SI really grew out of a need for, well, a more unified and consistent way to measure things globally. Our sources mentioned earlier systems like the centimeter-gram second system, CGS.
CGS, right? Heard of that?
It was an improvement over older, more local units, but it had its own problems.
Yeah.
Especially with electricity and magnetism, things got messy, different variations popped up. There wasn't great coherence across different fields.
So scientists in different areas were kind of speaking slightly different measurement languages.
Kind of, yeah. Made things difficult.
Yeah.
The real game changer was the Meter Convention in 1875.
1875, that sounds important.
It was huge, an international treaty. It led to setting up the big international organizations that still run the show today. The CGPM, General Conference on Weights and Measures,
Right.
the CIPM, International Committee for Weights and Measures, and the BIPM, International Bureau of Weights and Measures. They oversee and maintain the SI.
The governing bodies.
Exactly.
Right.
And their first job was basically to create and maintain internationally agreed upon standards for the meter and the kilogram. This formed the basis of the meter kilogram second, or MKS system.
Okay, so late 19th century, we get the organizations and the MKS Foundation. What happened next?
Well, early 20th century, an Italian physicist, Giovanni Giorgi, pointed out that MKS was still lacking when it came to electrical units.
The E&M problem again.
Right. He proposed adding a 4th base unit, which eventually became the ampere A for electric current, that gave us the MKSA system.
Getting closer.
Yep. Then, fast forward through lots of international discussion and scientific work, in 1960, the SI was formally established, initially with 6 base units.
6? I thought there were 7.
There are now. The mole, for amount of substance, was the final piece added, becoming the 7th base unit in 1971. That completed the set we knew until recently.
Until the big shakeup in 2019. That redefinition. Why did they do it? What was the driving force?
The 2019 redefinition was truly revolutionary for metrology. The core motivation was to get rid of the dependence on physical artifacts.
Like the kilogram prototype.
Exactly. Physical objects, even carefully preserved ones, can change over time, even minutely. They can be damaged, they drift. That introduces uncertainty.
Right. Not ideal for a fundamental standard.
Not at all. So the idea was to anchor the definitions entirely to fundamental constants of nature. Things we believe are truly constant and universal.
Like Planck's constant speed of light.
Precisely. So the kilogram, the ampere, the Kelvin, and the mole were all redefined based on setting exact numerical values for these constants. The meter and second were already defined that way, and even the candela definition was tweaked to tie it more explicitly to a constant.
So no more worries about Lagrange K losing a few micrograms and throwing global trade-off balance.
Metaphorically, yes. It makes the whole system inherently more stable, more robust, and actually more accessible.
More accessible. How so?
Because now, in principle, any well-equipped lab anywhere in the world can realize the definition of, say, the kilogram by conducting the right experiment based on the Planck constant. You don't need access to the artifact.
Ah, I see. Democratization of the kilogram.
You could put it that way. And interestingly, while this shift arguably makes the old distinction between base and derived units less fundamental, because all units now trace back to the constants that distinction is kept.
Why keep it?
Mostly for historical continuity and practical reasons. It's familiar, it works well pedagogically, and it aligns with how quantities themselves are organized in the broader international system of quantities, the ISQ.
Fascinating. Constant evolution towards abstraction and stability. Now, the SI is dominant, but not totally exclusive, right? There are other units we still use.
Yes, that's true. Our sources point out that some non-SI units are officially accepted for use with the SI.
Accepted, so they get a pass.
Kind of. It's usually because of long-standing tradition or just practical convenience in certain areas. Think about time. Minutes, hours, days.
Yeah, we're not switching to kiloseconds anytime soon.
Probably not. Same for the degree for angles. The liter for volume, though, it's just a special name for a cubic decimeter, and the ton for mass, which is just a megagram.
Ah, okay, so they have exact SI equivalents.
Exactly. 1 minute is precisely 60 seconds, 1 hour is 3,600 seconds, and so on. They're defined in terms of SI units.
Can you use prefixes with these accepted non-SI units?
With some, yes. A common one is the hectare for land area. That's 100 Rs, and an R is 100 square meters. So a hectare is 10,000 square meters, or 10 arctimeters. You see hecto prefix there.
Okay, but it's important to distinguish these accepted ones from other metric units that maybe aren't part of the SI family.
Yes, definitely. And another thing to be careful about, which the sources mention, is mixing information about the quantity into the unit name itself.
What do you mean?
Like saying something has an output of 100 watts peak. Instead of just saying the unit is watts, W, and specifying what kind of power you measured, peak power, average power, whatever, keep the unit clean and describe the quantity separately.
Right. Don't muddy the unit. Clarity is key. Okay, so we have these incredibly precise abstract definitions based on constants. But how does a lab actually do that? How do they make a real-world measurement that matches the definition?
Ah, the practical side. This is the distinction between the definition of a unit and its realization.
Definition versus realization. Okay.
The definition is the abstract rule, tied to the constant. The realization is the actual experimental procedure you follow to create a physical standard or perform a measurement traceable to that definition. And the BIPM, the International Bureau of Weights and Measures we mentioned, plays a key role here. They publish documents called mise en pratique.
French. What does that mean?
Practical implementations. Basically, they're like official guidebooks. They describe recommended methods and best practices for laboratories to realize the base units according to their definitions, achieving the highest possible accuracy.
So it's the how-to guide for making a real kilogram based on Planck's constant, or a real second based on cesium atoms.
Exactly. And what's great about defining units via constants is that measurement technology is always improving. So the BIPM can update these mises en pratique with new, more accurate experimental techniques as they're developed without having to change the fundamental definition of the unit itself. The definition based on the constant remains stable.
Ah, that's clever. Allows for progress and accuracy without rewriting the foundations.
Precisely. And the official SI brochure makes it clear. Any method consistent with the laws of physics can, in principle, be used to realize an SI unit. For some units, there might even be several different approved mises en pratique, reflecting different experimental pathways to the same goal.
Wow. This has been genuinely illuminating, a real deep dive into the SI. So just to sort of wrap things up, we've seen the SI as this incredibly coherent decimal system. It's built on this bedrock of fundamental constants, giving us a universal language for measurement everywhere, from science labs to, well, everywhere else. And its history shows this constant drive towards more abstract, more stable, more universal definitions.
Absolutely. And understanding the SI, it's really more than just knowing units like meters or seconds. It gives you a much deeper appreciation for the sheer level of precision and standardization that makes modern science, technology, and even global trade possible.
Yeah.
It's a fundamental piece of how we collectively understand and interact with the physical world around us. It's quite profound, really.
It really is. So on that note, maybe a final thought for you, the listener, to mull over. Now that you know a bit more about the fundamental basis of these units, that they're tied to unchanging constants of nature, how might the ongoing search for even better ways to realize these units, even greater precision, how might that continue to fuel future scientific discoveries and technological breakthroughs?
Interesting question.
Yeah. What doors might open as our ability to measure the universe gets ever sharper, all built on this remarkably stable and universal SI foundation? Something to think about. Thanks for joining us on this deep dive.
Welcome to the Deep Dive, and welcome to you listening in. This exploration is built just for you, using the really fascinating sources you shared with us about the Hindu deity Shiva.
That's right. And Shiva, as your material points out right away, is, well, he's one of the main deities in Hinduism. He's the supreme being for Shaivites, but also known worldwide as part of that Hindu trinity, the Trimurti.
He really stands out for being so multifaceted, doesn't he?
Absolutely. So many layers.
So our mission today is to unpack the key info from your sources, maybe find some surprising connections, and just give you a solid, clear understanding of this really complex figure without you having to read everything yourself.
Yeah, there's a lot there. The sources cover, everything from potential ancient origins, his different identities, roles, the symbols.
Right, and his place in different Hindu traditions, and even how he shows up outside India. It's quite the journey.
It really is a deep well, like you said.
Okay, let's dive in then. Your material kicks off with the basics. Shiva, principal deity, supreme in Shaivism, member of the Trimurti, and his name Shiva. What does that actually mean?
It means the auspicious one, which is interesting because, as we'll see, that sits alongside some much fiercer aspects.
Like Mahadeva, the great god, or Hara, those names feel different.
They capture different facets, and his roles show that same paradox immediately. In the Trimurti, he's usually called the destroyer.
But your sources stress, in Shaivism, he's way more than that. He creates, he protects, and he transforms the universe. Destruction is just part of that transformation.
Exactly. That's a key point. From your sources, he holds these seemingly opposite qualities: benevolent, kind, but also fearsome.
The ultimate yogi, totally detached.
And also a householder with Parvati and his sons.
Yeah.
It's that duality again.
It seems core to him. Your sources list his affiliations to Trimurti, Ishvara. In Shaivism, he's even equated with Parabrahman, Paraman, the ultimate reality itself.
And crucially, his connection to Shakti, the supreme goddess, the energy, the creative power. She's his equal complementary partner. That's very clear in the material.
And he's also one of the 5 deities in the Smarta tradition's Panchayatana Puja, so acknowledged alongside Vishnu, Devi, and others.
Right, as different paths or aspects of the one ultimate reality. It shows a kind of inclusiveness.
So with all this complexity, where does he even come from? Your sources dig into the history and they say it's complicated.
Very complicated and debated. There's talk of possible non-Vedic, maybe tribal roots, and a definite link to the Vedic deity Rudra, the storm god.
The scholarly view presented seems to be that Shiva, as we picture him now, didn't just appear, he sort of amalgamated.
Yes, amalgamation is the term used. A synthesis of various older figures and traditions, both Vedic and non-Vedic, brought together over a long time through processes like Sanskritization.
And finding early proof is tricky. Your sources mention those Mesolithic rock paintings.
Right, some people interpret them as Shiva, maybe dancing or hunting. But the sources are quick to say, that's really controversial. Many scholars see them differently. Group dances, maybe.
Then there's the famous Pashupati seal, Indus Valley. Much older.
Yeah, circa 2350, 2000 BCE. It shows this figure, looks like he's in a yoga pose, surrounded by animals. They called it Pachupati because that's one of Shiva's titles, Lord of Animals.
But again, your sources inject caution here. Is it definitely proto-Shiva?
Well, that's the debate. Some scholars think it's strong evidence. Others question if it's even human. Some see bull features. So it's important, yes, but its direct link to the later Shiva isn't settled science,
The sources also bring up possible links outside India, like Greece, Dionysus.
Yeah, proposed Proto-Indo-European connections, or maybe later exchanges. Similarities in iconography, bulls, snakes, and themes like wildness, anger, dancing, the mix of terror and bliss.
phallic symbolism too, apparently. And ancient Greeks actually called Shiva the Indian Dionysus.
They did. But just like the seal, your sources immediately give the other side. Many scholars reject these links, arguing Shiva's origins are purely indigenous, non-Aryan, so you see the layers of debate in trying to trace him back.
Okay, so moving into the Vedic period itself, the connection to Rudra seems much clearer.
Oh, absolutely. Rudra, the Rigvedic storm god, fearsome, destructive, yes, but also bringing life-giving rains. And that beneficial side, that was seen as his Shiva aspect, his kind or auspicious nature.
Your sources even quote the Rig Veda saying Rudra has two natures, wild, cruel, and kind, tranquil.
Exactly. And that helps explain how the word Shiva, initially just an adjective meaning kind used for lots of gods, gradually became the proper name Shiva in later texts, like the epics and Puranas. He absorbed both the destructive and the creative powers.
And linking Rudra Shiva with Nandi the bull as his vehicle later on helped cement that unified identity.
Right. Your sources also point out a strong link between Rudra and Agni, the Vedic fire god. They shared epithets like bull, suggesting Agni also fed into this evolving Rudra-Shiva complex.
And then there's Indra. Your sources mention a hypothesis from Wendy Doniger that some Shiva traits, fertility stuff, mountains, fierceness, maybe even the Auzum sound, might actually come from Indra.
Which is surprising, isn't it? But the term Shiva was apparently used for Indra too, back in the Rig Veda. And there are similarities noted in descriptions of Indra dancing in Jain texts and the later Shiva Nataraja figure.
Wow. So the picture your sources paint isn't one single origin, but more like a gradual building up, drawing from storms, fire, maybe tribal figures, other Vedic gods.
Precisely. A figure emerging over centuries, integrating all these different strands, plus later philosophical ideas.
Which brings us to how he went from maybe a lesser figure, Rudra, to being seen as supreme. Your sources flag the Shvetashvatara Upanishad as key here, around 400-200 BCE.
Yes, possibly the earliest text we have that really identifies Rudra or Shiva as the creator, the liberator, and explicitly equates him with Brahman, the ultimate reality. There's that famous line, Rudra is truly one, for the knowers of Brahman do not admit the existence of a second.
Though your sources add a note of scholarly caution, some read the Upanishad differently, maybe more pluralistic or henotheistic, but still a major moment.
Definitely a turning point. And after that, say 200 BC to 100 AD, the Shaiva tradition, focused solely on Shiva, really seems to take off. Your sources mention references to Shiva devotees, ascetics, in big texts like the Mahabharata and the Mahabharata from around then.
And we start seeing art, too. Gantara, Kushan coins.
Yeah, figures identified as Shiva, sometimes called Osho. There can be debates about specific images, but attributes like the trident suggest he was being revered in iconic form by the Kushan era.
Then comes the dedicated literature, the Shaiva Upanishads.
Right, 14 minor Upanishads specifically praising Shiva as Brahman, as Atman, the ultimate self within.
And they get philosophical. Your sources quote the Kaivalya Upanishad about self-realization being about seeing himself in all beings and all beings in him. That sounds very monistic.
It points towards that view, yes, where the individual self and the ultimate Shiva reality are one and the same.
Then the Puranas, like the Shiva Purana, Linga Purana, they fill in the stories, the cosmology.
Absolutely. Myths, aspects, how the universe works according to Shaivism. And then later 8th to 11th centuries, you get the Tantra literature.
Which adds even more philosophical layers, dualism versus monism.
Exactly. Some tantric schools, like Shaiva Siddhanta, might see the self as distinct from Shiva, but others, the Advaita or monistic ones, see Shiva as the self, present in absolutely everything living, non-living, no difference.
Wow. So Shiva is literally in everything in that view.
Pretty much. And this whole body of literature, Upanishads, Puranas, Tantras, really fueled his popularity across India, places like Kashmir, Tamil Nadu, and even spread to Southeast Asia, blending with local beliefs there.
Okay, so let's try to position him within Hinduism today, based on your sources, starting with Shaivism itself.
Well, for Shaivas, as your sources clearly state, Shiva is the supreme being. He's everything. Creator, preserver, destroyer, but also the one who reveals truth and conceals reality through Maya. He's all and in all.
And there are different streams within Shaivism, Vedic Puranic versus Tantric.
Broadly speaking, yes. Your sources give examples like Shaiva Siddhanta, Lingayatism on one hand, maybe the more esoteric Kapalikas or Kashmir Shaivism, reflecting Tantric influence.
What about his relationship with Vaishnavism, Vishnu's tradition? Is it rivalry?
You might expect that, but your sources suggest it's more nuanced. They say, while each tradition's texts usually elevate their main deity, both are generally pluralistic. They acknowledge and often respect the other's gods.
So they don't just ignore each other.
Not at all. Your sources actually quote the Skanda Purana saying, Vishnu is no one but Shiva, and he who is called Shiva is but identical with Vishnu. That's pretty direct.
So less rivalry, more complementarity, or different facets of the same ultimate thing.
That seems to be the view presented. The Mahabharata is even mentioned as declaring the identity of Brahman, Shiva, and Vishnu. Different paths, perhaps, to the same goal.
Okay. And Shaktism, where the goddess, Devi, is supreme. Where does Shiva fit?
Not as a subordinate. Your sources are clear. He's her equal, complementary partner. If she's the dynamic energy, Shakti, he's often seen as the static consciousness, Shiva or Purusha, that she activates. They're inseparable.
There's early evidence cited, too, like the Rig Veda's Devi Sukta showing respect for the feminine alongside Rudra Shiva. And later texts show Shiva and Vishnu revering the goddess.
And the ultimate symbol of this is Ardhanarishvara, right? The half-man, half-woman form.
Exactly. Representing that perfect synthesis of masculine and feminine energies, Purusha and Prakriti, they literally can't be separated in that icon.
Then there's the Smarta tradition, their Panchayatana Puja.
Right, worshipping 5 deities as equals in a special pattern. Shiva, Vishnu, Devi, Surya the sun god, and usually Ganesha or a personal deity.
And the Smarta philosophy, as your sources explain it, sees these different icons as just aids. Ways to focus the mind on the formless Brahman, aiming to realize that your own self, Atman, is Brahman, non-duality.
And this isn't a new idea. There's historical evidence going back centuries.
Seems so. Gupta Empire? Maybe even Kushan times.
Now, yoga. This seems like a really fundamental connection for Shiva.
Oh, huge. He's the Adi Yogi, the first yogi. Mahayogi, the great yogi, Lord of Yogis. He's essentially the source, the ultimate teacher of yoga.
And in that role, he represents samhara, dissolution, but not just destruction.
Right. It includes dissolving misery, dissolving the illusion of Maya, transcending limitations. As Dakshinamurti, he's the silent guru, teaching that ultimate oneness of self and Brahman just through presence.
Your sources mention specific yoga texts where he's central, like the Isvara Gita, Shiva's song, and his influence on Hatha yoga, dance.
And those monistic ideas in texts like the Shiva Sutras, there's a great quote included from Abhinavagupta, the Kashmir Shaivite philosopher.
Oh, yeah.
About how Shiva-focused spirituality and yoga helps you look beyond just yourself, see the interconnectedness of everything, and find bliss not just for you, but for the world. It connects the inner practice to a bigger picture.
That's powerful. And finally, just to round out his position, the Trimurti again. Brahma, the creator, Vishnu, the maintainer, Shiva, the transformer destroyer.
The classic Hindu triad. Though your sources do add that Hindu texts actually have lots of different triads, not just this one. But it's certainly the most famous one involving Shiva.
All these roles and ideas are reflected in how he looks, right? His iconography. Your sources say it's full of paradox.
Deliberately so, it seems. Let's unpack some key features. The third eye is probably the most famous.
Triambakam, the eye that burned desire.
Yes, burned to ashes. But the name itself, your sources note, could mean three-eyed or maybe three mothers, hinting at older connections. It represents insight, higher perception too.
Then the crescent moon on his head, Chandrasekhara.
Yep, linked to Soma, the moon, and seems to appear as Rudra Shiva rises in prominence.
And the ashes covering his body, Bhasma or Vibhuti.
That's deeply symbolic. Your sources explain it represents impermanence, everything returns to ash, and the importance of seeking the eternal spiritual reality beyond the physical. A constant reminder.
His hair matted, the Jain, and the Ganges flows from it.
Right, hence the name Gangadhara, bearer of the Ganga. The matted locks are very characteristic of ascetics.
And the blue throat, Nilikata, that's from drinking poison.
From the churning of the ocean myth, the Samudra Manthana. He drank the Halahala poison to save everyone. Parvati stopped it in his throat, turning it blue. Symbolically, your sources suggest it's about facing the world's poison's negativity, abuse with calm strength.
He's often shown meditating, usually on Mount Kailasa, sitting on a tiger skin.
Classic yogi image. And the serpent around his neck. That's Vasuki, blessed by Shiva after helping churn the ocean.
His main symbol or weapon is the trident, the Trishula. What does that represent?
Multiple things, according to your sources. His three core functions: creation, preservation, destruction, or the three gunas, the cosmic qualities. Sattva, Rajas, Tamas, balance.
And the little drum, the Damaru.
Yes, the hourglass drum. He in his Nataraja dance form, symbolizing the rhythm of creation, the primal sound. Also used by the Kamalika sect. Sometimes he holds an axe-hair parashu or a deer too in regional images.
Whereas Rudraksha beads, the rosary.
Symbolizing grace, meditation, the mendicant life. His vehicle, of course, is Nandi the bull.
Linked to that Pashupati name, Lord of Animals.
Exactly. His home is Mount Kailasa, seen as resembling a linga, the cosmic center. And his attendants, the Gattas, often ghost-like Budaganas. Ganesha is their leader, Gatapi.
And Varanasi, Kashi, the city he particularly loves, a major pilgrimage site. It's like every detail tells a story.
It really does. And these attributes combine in specific forms, or murti. Again, dualities are key. Fierce names like Rudra, Bhairava.
Versus gentle ones like Sakara, Sambhu, Beneficent.
And that ascetic versus householder tension. The lone Mahayogi versus Shiva with Parvati and his sons, Ganesha and Kartikeya. Parvati and his consorts, Sati, Durga, Kali, are seen as his Shakti, his power.
Your sources even mention other kids from regional myths. Ayapan, Manasa, even debated links to demons.
Yes, the mythology is vast and varies. But let's look at some major forms. Nataraja, Lord of Dance, is huge.
Two kinds of dance, Tandava and Lasya.
Right. Tandava is the powerful, fierce, masculine dance, often linked to destruction. Lasya is graceful, gentle, feminine, attributed to Parvati, linked to creation. Together, they represent the whole cosmic cycle.
Nataraja is described as more than just dance. It's like a visual representation of Brahman, ultimate reality, linked to consciousness, the 5 elements.
A very profound symbol. Then there's Dakshinamurti.
The teacher aspect, teaching yoga, wisdom, silently, mostly seen in the south.
Particularly Tamil Nadu art, yes. Teaching sages.
Bhikshatana the mendicant, begging bowl, nude.
Associated with penance, particularly for the sin of killing a Brahmin, committed in his Bhairava form. Stories connect him to encounters in the Deodar forest in the skies.
Triparantaka, destroyer of the 3 demon cities, a warrior form.
Yep, shown with weapons like axe, deer, bow and arrow, representing his power to overcome evil.
Ardhanarishvara, we mentioned this one, half Shiva, half Parvati.
The ultimate symbol of the unity of masculine and feminine, Shiva and Shakti, Purusha and Prakriti.
Absolutely inseparable.
Kalyanasundara, that's the wedding scene. Yes, Shiva marrying Parvati, performing the hand-holding ritual, often with other gods like Vishnu present. A joyful depiction.
So Maskanda Shiva, Parvati, and their son Skanda together. Popular in the Pallava era.
Right, emphasizes the divine family. Your sources also list Astamurti, Shiva, as 8 forms, and Panyakanana, or Panyaka Brahma, 5-faced Shiva.
5 faces? Why 5?
5 is a sacred number for Shiva. Think of the mantra Namah Shivaya, 5 syllables. The 5 faces represent his 5 divine activities: creation, preservation, destruction, concealing grace, revealing grace.
And I link to elements, senses.
Yes, Sadyojata, Vamadeva, Agora, Tapuro, Esana, each linked to an element, a sense, an organ of action. The Panigrama Upanishad quoted in your material ties the 5-fold nature of the world directly to Shiva's 5-fold nature as Brahman.
So these forms aren't just pictures, they're like condensed philosophy.
Beautifully put. And beyond these human-like forms, there's the most important aniconic form, the lingam.
Right. The pillar or oval stone on the yoni base, found in the heart of temples.
The central focus of worship for many. Your sources explain linga means sign or mark or emblem. It's seen as a manifested sign of the divine, specifically the regenerative divine energy in nature.
There's an interpretation from the Shvetashvatara Upanishad too.
Yes, where linga means the imperishable Purusha, absolute reality, a mark of Brahman's existence. Interestingly, the same Upanishad says Shiva has no liga, using a different word to imply he's ultimately transcendent, beyond characteristics like gender.
Capturing that paradox again. The formless worship through form.
Exactly. Now, your sources tackle the common interpretation, the lingam, as just a phallic symbol.
And they push back against that.
Strongly. They cite figures like Vivekananda, Sivananda, scholars like Kramrish who call that view a serious mistake or grave blunder. They argue it's a limited, often Western misreading.
So what's the alternative origin suggested?
From the Vedic Upastamba, the sacrificial post, or cosmic pillar, symbolizing the endless Brahman. The idea is that this ancient symbol evolved into the Shiva Linga. The Linga Purana elaborates on this story.
And there's archaeology, the Gudimalam Lingam.
3rd century BCE, one of the oldest known. Plus the 12 Jyotirlingas, the lingas of light, major pilgrimage sites across India.
So the lingam is incredibly rich in meaning, far beyond just one interpretation.
Deeply symbolic, yes. Representing the cosmos, transcendence, immanence, creation, all wrapped up in that seemingly simple form.
Okay, quick question. Avatars. Vishnu has famous ones. Does Shiva?
It's different, according to your sources. The idea isn't as central or systematic in Shaivism. You don't have a list of 10 main Shiva avatars like Vishnu's Dashavatara. Sometimes texts mention portions or forms, but it's not the same concept.
But some figures are linked to him, like Hanuman.
In some traditions, yes. The Hanuman Chalisa calls Hanuman the 11th Rudra avatar, an aspect of Shiva. The sage Durvasa is sometimes called a portion of Shiva.
And Adi Shankara, the philosopher?
Some medieval texts identify him as an incarnation. So connections exist, but it's maybe less about direct descents and more about embodiments or aspects.
Got it. Let's talk festivals. Shiva seems central to some major ones.
Absolutely. Mahashivratri is the big one. The great night of Shiva, late winter or spring.
And it's quite solemn, focused on overcoming darkness.
Yes. Lots of meditation, prayer, fasting, yoga, reflecting on ethics, honesty, forgiveness, remembering Shiva, visiting temples, offering to the lingam, staying awake all night, and dance, honoring Nataraja. It's ancient, maybe 5th century origins.
Then there's Kartik Purnima,
commemorating his victory over the Tripurasura demons. Lots of lights, processions.
Thiruvathira in Kerala celebrating his marriage to Parvati.
Yes. After her long penance, women perform a special dance, Thiruvathira.
The Chitharai festival in Madurai sounds interesting, celebrating the marriage of Meenakshi, Parvati, and Shiva, but with Vaishnavas involved.
Right. Vishnu is depicted giving Parvati away. It shows the Shaiva-Vaishnava connection in practice.
He's also part of Shaktism festivals and Tej in the Himalayas.
Honored alongside the goddess. Tej focuses on Parvati, but includes prayers at Parvati Shiva temples.
And the Kumbh Mela, the giant pilgrimage.
Shiva has a strong presence there, especially through the Naga Sadhus, the ascetic warriors linked to him, who traditionally lead the bathing rituals. Your sources even mention a huge Shivaratri festival in Pakistan at Umarkot. Shows his reach.
Clearly huge within the subcontinent, but your sources also track his influence beyond Indonesia.
Yes, Java, Bali. He's known as Batara Guru, noble lord, seen as a teacher, like Dakshinamurti, but also blended with local figures. Durga is often his consort there.
And the relationship with Buddhism there is interesting.
Very. In medieval times, Shaivism and Buddhism were seen as close allies. Some texts even equate Buddha with Shiva and Vishnu. In modern Bali, Buddha might be called Shiva's younger brother.
Wow. And Central Asia, too.
Through groups like the Kushans. Wall paintings found in places like Sagdi show Shiva halo, tiger skin, sometimes with local attendants. There's even mention of a Trimurti form of Shakti and a strange four-legged depiction.
Even influenced Zoroastrianism locally.
Apparently, the wind god Vayuvada took on Shiva-like imagery in some depictions there. Fascinating overlap.
What about Sikhism?
References in the Guru Granth Sahib, like the Guru is Shiva, and Rudra avatars mentioned in the Dasam Granth, acknowledged, integrated in certain ways.
And Buddhism more broadly.
He appears in Buddhist contras, often worshipped as the fierce protector Mahakala in Vajrayana Tibetan Chinese traditions, though sometimes depicted as passive, with Shakti Prajapati as the active force.
Is he seen as a Buddha sometimes?
In Mahayana, sometimes as Maheshvara, a high deva, or even Bhasmeshvara Buddha, Buddha of ashes. In Theravada, he's Ishana, also a high deva. But generally, your sources say his rank in Buddhist cosmology is below figures like Mahabrahma or Indra.
Still, he's one of the protectors of the Dharma in East Asia.
Yes, one of the 20 or 24 devas in China, Taiwan. Statues and temples, paintings. Even shows up as one of as far as 33 forms of the Lotus Sutra.
And Japan. Daikokuta.
The god of wealth, evolved from Mahakala Shiva, sometimes fused with the local kami, Shunanushi. And Akala is another fierce adaptation found in China and Japan.
It's incredible how he travels and transforms across cultures and religions.
Truly remarkable adaptability and resonance.
And finally, your sources touch on pop culture today.
Right. Films, TV shows like Om Namah Shivaya or Devin K. Dev Mahadev, books like the Shiva trilogy. He's still very present.
Someone apparently called him the god of cool things and a bona fide rock hero.
Yeah, capturing that rebellious, powerful, yet deeply spiritual vibe he has. It somehow fits, doesn't it?
It strangely does. Okay, so we've covered a huge amount from your sources. Origins, identities, roles, history, philosophy, art, worship, his travels. It's mind-bogglingly rich.
It really underscores his complexity, doesn't it?
Okay.
A single figure holding so many paradoxes, playing so many roles, with such deep roots across Asia and beyond.
We've definitely only scratched the surface of the detail in your material, but hopefully this gives you, our listener, a much clearer, richer picture of this truly pivotal deity.
And maybe something to mull over, drawing from the sources. They point out this profound paradox. Texts like the Linga Purana describe Shiva as fundamentally signless beyond attributes, transcendent the formless Brahman.
Right, the ultimate reality that can't be described.
And yet, he's most widely worshipped through perhaps the most potent tangible sign there is the lingam.
The signless, worship through the sign.
So what does that tell us? This embrace of paradox, the formless expressed through form, the transcendent found in the immanent. What might that say about reality itself and maybe our own human need to connect with the infinite through the finite?
Definitely something to keep thinking about. Thanks for bringing us these sources for this deep dive today.
Okay, let's jump right into the deep dive.
Yeah, let's do it.
This is where we take, a single source, really get into it, and pull out the most interesting bits.
We sift through it all, basically. Find those surprising facts, the aha moments you might otherwise miss.
Exactly. And today, wow, we're diving into something truly iconic, icebergs. We all picture that, like white peak above the water, don't we?
Sure, the classic image.
But our source today, a really detailed Wikipedia article just on icebergs.
Yeah.
Well, it shows there's so much more going on underneath.
Yeah.
Just like the iceberg itself.
That's the perfect analogy for it, really.
So our mission for you listening is to get past that simple picture.
Yeah, we want you to really understand these massive floating giants. What makes them tick?
We'll dig into the physics, their journey, even their, well, weirder side, all based on what this article lays out.
Let's get started.
Okay, let's unpack the basics. What is an iceberg, according to this source? The name itself kind of gives it away, doesn't it?
It does, yeah. Iceberg. It's partly from the Dutch iceberg.
Which means?
Literally ice mountain.
Ice mountain. Okay, that sets the scene for the scale.
Definitely. And the definition here is pretty clear. It's a chunk of freshwater ice that's important.
Right, not salty.
No. Broken off a glacier or an ice shelf, and it's floating out in open water. And crucially, it has to be over 15 meters long.
Over 15 meters.
Okay.
Okay, so anything smaller isn't technically an iceberg.
Correct. The source gives us names for the smaller ones, too.
Oh, yeah.
Little guys, less than a meter showing above water, less than 5 meters long overall. Those are called growlers.
Growlers, huh?
Then a bit bigger, 1 to 5 meters above water, 5 to 15 meters long. Those are bergy bits.
Growlers, bergy bits. Then icebergs.
Got it. And this leads right into that famous phrase, tip of the iceberg.
Exactly. The source explains the science behind it. Archimedes' principle.
Right. How does that work here?
Well, it's about density. Ice, being freshwater, is less dense than salty seawater.
Okay.
About 920 kilograms per cubic meter for ice versus maybe 925 for seawater.
So because it's less dense, only about 1/10 of the iceberg's volume is usually above the water.
Volume, not height or weight. That's a key detail.
It really is. And the source stresses, and you really can't judge the underwater shape or size accurately just by looking at the top.
Makes sense why it's such a great metaphor then. What you see is just a tiny fraction.
Precisely.
Okay, let's talk scale, because the numbers in this article are just mind-blowing.
They really are. Masses from, 100,000 tons up to over 10 million tons.
Whoa. And height. How tall can they get?
They can soar over 100 meters above the sea. The source actually gives a record for the North Atlantic.
Yeah. What was it?
168 meters. That's 551 feet back in 1958.
168 meters. The article compares that to a building, right?
Yeah, like a 55-story building just floating there.
A 55-story ice building. That's wild. And there's a formal size classification system.
Based on height and length. You've got the growlers and bergy bits we mentioned.
Right.
Then small, medium, large, and very large icebergs.
What counts as very large?
Over 75 meters high and over 213 meters long. Those are the big ones.
And where do the absolute monsters come from?
Antarctica.
Yeah.
Definitely. From the huge ice shelves down there, like the Ross Ice Shelf, that's where the biggest ones calve off.
The source mentions a record holder from 1956.
Oh, yeah, the tabular one measured something like 335 by 97 kilometers.
Kilometers. Hold on. 335 by 97? The comparison was?
Belgium, yeah. That single iceberg was bigger than the entire country of Belgium.
Bigger than Belgium, an ice island, basically.
Pretty much. And those Antarctic ones are often those huge, flat-topped tabular bergs.
Whereas Greenland icebergs are different.
Yeah, they tend to come off glaciers differently, so they're usually much more irregularly shaped, not so table-like.
Which brings us to shapes. The source breaks them down, right? Two main categories.
Yep. Tabular versus non-tabular.
Tabular is the flat top, steep sides, like a plateau, sometimes called ice islands.
That's the one. Length much greater than height, typically Antarctic.
And non-tabular is everything else.
Basically, yeah. And they get descriptive names based on how they look.
Like what?
Well, there's dome, kind of rounded top. Pinnacle got spires sticking up. Wedge, steep one side, sloped the other.
Okay.
Then dry dock, that's one that's eroded, formed a channel or slot in it.
Huh.
And blocky steep sides, flat top, but not as wide compared to its height as a tabular one.
So lots of variety. Now, they break off, they start floating, but how do they actually move? The source says it's pretty complex.
Oh, incredibly complex. It's not just, wind pushing it or currents pulling it.
Yeah.
It's a whole mix of forces acting on that massive underwater part, too. Air drag, water drag, waves hitting it, bumping into sea ice.
What else?
Even things called pressure gradients in the water.
Pressure gradients. What's that?
Think of it like tiny slopes in the sea surface or within the water layers caused by differences in density or height.
Okay.
Water tries to flow down these subtle slopes, creating currents. And iceberg is so big, it gets influenced by these subtle flows. It adds to the unpredictability.
Right, so all these forces are kind of battling it out. And while they're drifting, they're also deteriorating.
Yeah, they melt and they fracture, break apart.
What's the main cause of melting? The sun?
Actually, no, not primarily. The source says most melting comes from the ocean itself.
How so?
Just the transfer of heat and salt from the warmer, saltier seawater surrounding the ice. Plus, wave erosion chips away at the waterline.
And the source mentioned something really cool, how the shape and even the Earth's rotation affect melting.
Yeah, the Coriolis effect. That slight turn caused by the Earth spinning. For something huge like an iceberg, that effect can subtly change how water flows around it, which impacts how heat gets transferred and so how fast it melts. Lab experiments showed this.
Wow, so the planet spinning actually influences how an iceberg melts. That's amazing.
It is pretty cool. The melting models mentioned in the source consider things like how fast the berg is moving relative to the water, the temperature difference, and its size, of course.
And they can interact physically, too, pushing into things.
Oh, yeah. Winds and currents can shove them into pack ice or into shallow water. They can literally grind along the bottom. It's called seabed gouging. Imagine the force needed to carve trenches in the ocean floor.
Seabed gouging. Yeah. Incredible power. Okay, let's shift to some of the wonders and oddities that source highlights. I love this Bergy seltzer thing.
Ah, yes. The sound.
What causes that?
It's trapped air bubbles. When the glacier formed, snow trapped air, which got compressed under immense pressure over thousands of years.
Okay.
The source says up to 10% of an iceberg can just be these ancient air bubbles.
10%.
So as the ice melts at the surface, these compressed bubbles are released and they pop or fizz.
Like opening a really, really old can of soda.
Exactly. That's the Bergy seltzer sound.
And scientists can actually use that sound.
Yeah, the source mentions they can listen to it to help figure out how fast the ice is melting.
That's brilliant. Another hazard mentioned is capsizing, right? They can just flip over.
Without warning, yeah. As they melt or trunks break off, their balance shifts.
Suddenly, the center of gravity is wrong. And whoosh.
Precisely. It can happen anytime, really, early on or much later. They're fundamentally unstable things.
And the really big ones capsizing can cause... What was it?
Glacial earthquakes.
Seriously?
Yeah, if a huge berg flips near the glacier front, the force can be so immense it actually pushes the whole glacier backward momentarily, creating seismic waves.
Glacial earthquakes. Never heard of that. Shows the power involved.
Absolutely. And then there's their color. We think white, but the source says, nope.
Not always white. They can be green, blue, black, striped.
All of the above. White is usually snow cover or lots of internal bubbles scattering light.
But the other colors?
Green or blue can come from things like trapped seawater, algae, or really dense old ice with few bubbles that absorbs red light.
Okay.
Black or brown streaks or stripes, that's usually sediment. Dirt and rock ground up by the glacier and frozen into the ice layers.
So you could have these incredibly colorful striped ice mountains. Amazing.
It makes you look at them differently, doesn't it?
It really does. Now, humans and icebergs. A long history, mostly about avoiding them, I guess.
Yeah, especially after major disasters. The source walks us through how monitoring evolved.
Before 1914, nothing coordinated, even though ships hit them.
Sadly, yes. Then came the Titanic.
April 1912.
Yeah.
Over 1,500 lives lost. That changed everything.
It was the catalyst. Directly led to the International Ice Patrol, the IIP, formed in 1913.
And their job?
To patrol the North Atlantic shipping lanes, especially near the Grand Banks where icebergs drift south. They collect data weather, ocean currents, temperature, salinity to track the bergs and warn ships about the limits of all known ice.
And the technology they used improved over time, as the source details.
Hugely. Started with ship reports, then aerial surveillance in the 30s, radar experiments in the 40s.
Then computers.
Satellites.
Shipboard computers came in the 60s, satellite photos in the 70s, drifting buoys in the 80s to track currents. But a really big step was synthetic aperture radar, SAR, on satellites.
SAR, what's special about that?
Yep.
It can see through clouds and darkness, day or night, any weather. It can generate detailed images.
So reliable surveillance.
Exactly. Satellites like Canada's RadarSat or the European Sentinel satellites use SAR. It's crucial for modern tracking.
So today, it's mostly satellites watching them.
Very much so. The U.S. National Ice Center, the NIC, monitors them globally using satellites.
And they name them.
Yes, the source says the NIC is the only agency that names and tracks all the big Antarctic bergs anything over 10 nautical miles long. They use a letter number system based on where they calved off, A, B, C, D, for different longitude sectors.
Like A68 or B15 that we hear about.
Exactly. And around Greenland, the Danish Meteorological Institute does similar monitoring, also using SAR data.
Is there any management beyond tracking?
Well, the source mentions plans in places like offshore Newfoundland and Labrador, where they have oil rigs, to try and mitigate the risk if a berg gets too close. Towing, maybe, or deflection.
Which brings us to the idea of using icebergs, towing them for water.
Yeah, that idea has been around since the 50s. The source notes proposals to tow them to dry places like the UAE or South Africa.
Has it ever really happened on a large scale?
Not really for major water supply, it seems. The logistics are incredibly difficult. But there are niche commercial uses now.
Like what? Bottled water?
Yep, bottled water, fancy ice cubes. The source even mentions Creedy Vidi Iceberg beer in Newfoundland.
Made with iceberg water.
Apparently so. And there's even a specific tax and export limit on harvesting iceberg water commercially up there. A unique resource.
Huh. Who knew? Okay, beyond the human interaction, what about their impact on the ocean environment itself?
Oh, they have significant impacts. Oceanographically, all that fresh water melting off them is less dense than the salty seawater.
Right, so it floats.
It rises towards the surface, yeah. It can change local density, affect currents, and physically, a big iceberg can act like a floating breakwater, calming waves behind it.
And ecologically. You mentioned nutrients earlier.
That's a key point. Glaciers scrape up rock and soil as they move, and that sediment gets trapped in the ice.
Okay.
When the iceberg melts out in the ocean, it releases these trapped minerals, especially iron.
Iron. Why is that important?
Iron is often a limiting nutrient in parts of the open ocean. Adding it can fertilize the water, triggering blooms of phytoplankton, tiny marine plants.
So icebergs can actually seed life in the ocean.
They can, potentially. It creates hotspots of biological activity. Though the source does caution that the nutrient levels vary a lot between different icebergs.
Still a fascinating connection. The source also lists some of those giant recent icebergs by name and size.
Yeah, the scale is just hard to wrap your head around. B15 from 2000 was 11,000 square kilometers.
11,000 square kilometers.
68 in 2017, 5,800. A76 in 2021, 4,320. Just enormous areas.
And wasn't there something about B15 breaking up due to a storm far away?
Yes. A piece of B15 called B15A, its breakup might have been caused by ocean swells from a storm way up in Alaska, thousands of kilometers away.
Shows how connected things are, how powerful ocean waves can be over vast distances.
Definitely. And the source often uses Manhattan as a comparison to help grasp these sizes.
Right, Manhattan's about 59 square kilometers, so B15 was, what, nearly 200 times bigger?
Roughly, yeah. A68 about 100 times, A76 over 70 times Manhattan. It helps visualize it a bit.
It does. Finally, beyond science and shipping, icebergs have a cultural presence too.
Obviously, the Titanic looms large. It changed maritime safety forever and cemented the iceberg as a symbol of hidden danger.
But also as objects of awe, right? in art.
Absolutely. The source mentions famous landscape painters like Frederick Edwin Church, Caspar David Friedrich. They painted icebergs, capturing their, stark, remote beauty.
And poetry, too.
Yeah, Lydia Sigourney wrote about seeing them during the Northern Lights.
And that brings us back to the metaphor.
The tip of the iceberg. It's everywhere.
The source lists examples beyond just the obvious meaning.
Right. Hemingway's writing style, the theory of omission. Freud's model of the mind, conscious versus unconscious. Even in things like safety analysis or behavioral psychology, the idea that what's visible is just a small part of a much bigger, hidden reality.
So there we have it. We started with, that simple white triangle image.
Yeah.
And this deep dive, just based on this one source, has opened up this whole world. Complex physics, weird, sounds like Berge Seltzer, glacial earthquakes.
The whole history of tracking them, trying to use them, their ecological role releasing nutrients.
And their impact on our culture, our art, even our language.
It really demonstrates how much complexity can be hidden beneath a seemingly simple subject. That's the value of digging into a source like this.
Absolutely. And maybe that's the final thought to leave you with, building on that tip of the iceberg idea. How much remains unseen? Not just literally in the ocean, but maybe in the challenges we face, the systems around us, even in understanding each other. What icebergs are out there in your world where you might only be seeing the tip?
Something to think about, definitely. Keep digging into your own sources.
Keep asking questions.
Yeah.